Trigonometry is the branch of mathematics that deals with calculating, determining, and finding the lengths and angles of a triangle. Trigonometry is also the relationship between the sides and the angles of a triangle. The relationship between the sides and the angles of a triangle, that brings us to what we call trig ratio. Trigonometry ratio is simply the sine, cosine, and tangent. And this ratio is only applicable to a right angle triangle. Provided we have a right angle triangle, we can apply the trigonometry ratio. Now, a right angle triangle is simply a triangle in which one of its angle is a 90-degree angle. If this is our angle, let's call it theta. To find theta, which is our angle, or to find the side AC or side AB or side BC, let's call opposite side A small a. Let's call opposite side B small b, and let's call opposite side C here small c. Now, to find either side B, A, or C, we could use the trig ratio, provided we have our angle theta. Or to find angle theta, we could also use trig ratio, provided we have two of these sides, either C and A, or C and B, or B and A. Now, since this is our theta, B here is opposite theta. So side B is known as opposite because it is opposite theta. Now, side A here is the longest part, so it is referred to as the hypotenuse. Whereas AC, which is side C, is known as the adjacent. Therefore, to find either the angle or the side, we could use sine, which is sine theta from SOHCAHTOA, sine theta is opposite over hypotenuse. We say opposite over hypotenuse. And what is our opposite of sine theta? Our opposite of theta here is B, over hypotenuse here is A, and cosine theta, let's call it cos theta, which is CAH, adjacent. Where's our adjacent? Our adjacent is C, which is adjacent theta over hypotenuse, which is C over A, and tan theta is TOA, which is opposite versus adjacent, which is opposite theta over adjacent. And what is our opposite theta? Opposite theta here is B over adjacent, which is C. Hence, if you are looking for theta, which is our angle here, and you have side B and side A, we could choose to use sine theta. Also, if you're looking for B or you're looking for A, you could also use sine theta, provided you have your value for theta. Now, for cos theta, which has to do with C over A. So if you're looking for angle theta here, provided you have A and C, you could use cos theta. Or if you're also looking for A and you have theta and side C, you could use cosine theta. Now for tan theta, which means if you're looking for theta and we have B and C, we could use tan theta. So long we have B and side C, we could use tan theta to get our angle theta here, provided we have B and C. Also, if we have B and theta and we are looking for side C, we could use tan theta. Another method used to solve trigonometry, so long it is a right angle triangle, is the Pythagoras theorem. Now, also in Pythagoras theorem, it's only used to find the sides. Pythagoras theorem has no relationship with the angle. And using Pythagoras theorem, the longest side is known as the hypotenuse or slant height, which is represented by A, and the down part is known as the base or adjacent, and this side is referred to as, which is the opposite of the hypotenuse, is referred to as the opposite, or we call it perpendicular height. Therefore, the Pythagoras theorem states that to find the side with the longest part, which is side A, the square of it is equal to the square of the addition of the other side, which is B square plus C square, which means the hypotenuse square is equal to the sum of the adjacent square and the opposite square. Also, to get the adjacent, which is side C, the square of side C is equal to the square of the hypotenuse square minus the square of the opposite square. And also, to get the side B, you can say the square of B square is equal to the square of the hypotenuse square minus the adjacent square. So this is the formula used to solve question on trigonometry using Pythagoras theorem. Now if you look at this, this has nothing to do with our angle theta. So it is only used to find the sides of a right angle triangle. Let's discuss some trigonometry identity. Consider the diagram here with reference to theta. We said sine theta is equal to opposite of theta over hypotenuse. Also, we said cos theta which is adjacent of theta over the hypotenuse, and also tan theta, which is also opposite of theta over the adjacent of theta, cosec theta is equal to 1 over sine theta, whereas sec theta is equal to 1 over cos theta, and cot theta is equal to 1 over tan theta. So the inverse of sine theta is cosec theta, the inverse of cos theta is sec theta, and the inverse of tan theta is cot theta. Or we can say the inverse of cosec theta is sine theta, the inverse of sec theta is cos theta, and the inverse of cot theta is tan theta.